All right, sketch the hyperbola. X squared minus 9y squared plus 2x plus 36y minus 44 equals 0. How do I know that's a hyperbola? Because I see x squared minus y squared. So if we have the minus with the x and y both squared, that's going to be hyperbola. If we see x squared plus y squared, we know that's going to either be a circle or an ellipse in some way. If we just see a y squared and an x, we know that's going to be a parabola. Okay, so these are just some helpful tips for you to think about. When you see an equation, you can automatically determine what kind of conic section you're dealing with. So since we want to sketch the hyperbola, let's get it in the form we want, where we can graph it using the center and its values of a and b. Now, just like with the ellipse, what we want to do is group our terms together. So we're going to have our x's together. We'll have our y's together. Actually, I'll leave some space. And then we'll kick over the 44. All right, now in order to work with the x's, remember the idea here is you want to get you want to complete the square. So this will be the same as x squared plus 2x. Then 2 over 2 is 1, so we'll get plus 1 squared there. Now with the y, remember you want to factor out the negative 9, so that way you actually get the values you want here. So y squared minus 4y. Then to complete the square, we're going to take the negative 4 divided by 2 and square it. On the other side, we have 44 still. Don't forget though, when I should have color-coded this, when we added some extra terms there, we should also add on it onto the right side as well. And so we should also add this on as well. So plus a negative 4 over 2 squared. Don't forget, what else do you have? You have a multiply by negative 9. Okay? So in simplifying the entire left side now, this perfect square trinomial will become x plus 1 squared minus 9 times y minus 2 quantity squared is equal to, and then we're just going to add this up. Let's see, negative 4 over 2 is negative 2 squared is 4, so we'll get negative 36 here, plus a 1 and a 44. That'll give us 45 minus 36, that'll give us 9. Okay, so from here, remember that a hyperbola should be in the form of a 1 on the entire right-hand side. So we're going to divide everything by 9 here. And so that way we get x plus 1 quantity squared over 9 minus y minus 2 quantity squared over 1 equals 1. From here, we can now think about the a and b values, right? If we have again, actually, let's not think about it in terms of a and b. Instead, I want you to think about what kind of hyperbola you have. Now, because we see that there is an x squared minus y squared, then that's telling us, since x comes first, we have a horizontal hyperbola. Not only that, but because we have a horizontal hyperbola, that's telling us that also because the 9 is connected with the x, this is going to be the run because x runs. And then this value of 1 is going to be the rise because we know the y value rises. Okay, so our equation of the asymptote then will be in the form, some kind of form actually, of a rise, which is 1, over a run, which is 3, since the 9 is like a 3 squared, 1 over 3x, plus and minus 1 over 3x, something of that sort. Okay, so the reason why I say it's something of that sort and not actually that equation is because I also noticed one more thing. This problem's a little bit more complicated because you see the plus 1 here and the minus 2 here, telling you that your hyperbola is no longer the parent function, but it has actually shifted. Okay, so we need to apply a shift as well. So let's go ahead and graph the coordinate plane first. Actually, you know what? I am realizing because of the shift, I'm going to be a little bit more in quadrant 2, I believe. Okay, so I'm going to go ahead and plot some values here. So 1, 2, 3, oops, that's off. 3, 4, 5, let's do that. Okay, let's see if that's enough for us. Now I'm going to plot the center. I'll do everything in, let's do everything in red just so we can see everything. So my center of the hyperbola will be at, since it's plus 1, I'm going to go left 1, so negative 1, and then the minus 2 is going to tell us we go 2 up, so negative 1, 2. Negative 1, 2 is right here. That's my center. From the center, now let's think about what we have to do. Okay, keep in mind that the 1 represents the rise and the 3 represents the run. So from the center, we're going to go up 1 and to the right 1, 2, 3. This is going to be one of my corner points of my rectangle to form the asymptotes. Now if you go up 1 to the right 3, I can also go up 1 and left 3 as well. That's going to be another corner point to one of my rectangles, or to the rectangle. I can go down 1 and then over 1, 2, 3. There is another corner, and down 1 and 1, 2, 3. So these 4 corners represent the border of your rectangle. Okay? Now that you have the rectangle in place, you can now go ahead and construct the asymptotes, and the asymptotes are going to be done with a line, just like this. Remember, it's a dotted line, just like that. Okay? And then we're going to do the same thing on the other side. Just like that. Remember, it's a dotted line. Do not draw them as solid lines. If you draw them as solid lines, you're saying that the lines themselves are part of your hyperbola, but they are not, okay? So make them as dotted lines. Now we can actually just sketch in the hyperbola. If you recall, one thing that we had said was that the hyperbola itself, actually I'll do it in purple, the hyperbola itself was in the form of an x squared, where's my actual equation here? My equation was in the form of an x squared minus y squared, which means that is a horizontal hyperbola. So where is my vertex at? Well, if my center was at negative 1, 2, then it goes to say that right there along the edge, the same level as the center, my vertex is going to be at the point, what is that, 2, 2. That's the vertex. And then from there, we can draw our hyperbola, come up towards the asymptote. Remember, never touching it. And remember, you draw these curves. They're almost like parabolas, almost. But you make sure you draw them as curves. Don't draw them as V's, okay? They're curves at the bottom, or at the vertex, okay? All right, so there is one side of the hyperbola. Now let's draw the other one. Where's the other vertex? If we're at negative 1, 2, and we went to the right 1, 2, 3, we're now, or sorry, to the left 3, then we're going to be now at negative 4. Let's label them. That's going to be at 2, 2. And my other vertex was at negative 4, 2. Negative 4, 2. Okay, and then from there, we can sketch our hyperbola. Remember, come up towards the asymptotes. Never touching it. Don't touch it. Okay. All right, so there's our hyperbola, basically. But we also need one more thing. We got to find the foci. So the foci... The foci, I don't think I actually talked about them in the last video, but the foci can be found just like with an ellipse. The equation of foci can be found by doing c squared equals a squared plus b squared. Okay? Unlike the foci of an ellipse, which is c squared equals a squared minus b squared, if you'll notice, basically the formulas are switched. An ellipse equation has x squared plus y squared, right, like this, equals 1, but a hyperbola equation just has a minus sign, something like that. And so also the foci have been switched too. If the foci is c squared equals a squared minus b squared, this is c squared equals a squared plus b squared, so it's just switched. Okay, so to find the foci, we can go ahead and use our equations of c squared equals a squared plus b squared. And so our a and b are 9 and 1, so c squared equals 9 plus 1, or basically c is equal to plus minus the square root of 10. Remember, distance cannot be negative, so you're just talking about a square root of 10. So the distance is going to be a distance of square root 10. What is square root 10? That is about 3.16. Okay, so 3.16 from the center means you go over 1, 2, 3.16. That's why the foci is so close to the hyperbola, just like when we were talking about parabolas and their focus. Okay, and then on the other side you go 1, 2, 3, and another 0.16. That's where the other focus is going to be right there. Okay. So what is the ordered pair of the foci? Well, that's going to be, remember, what we're coming from is from the center, which is at negative 1, 2. So one of the focus points is going to be start from negative 1, and you're going to the right, so negative 1 plus square root 10, but the y value stays the same, so comma 2. And then the other focus is going to be negative 1, and now you're going to the left, so minus root 10, comma 2, like that. You can double check your work, make sure it's accurate. If we do negative 1 plus root 10, that's going to be the value of about 2.16. Okay, and so you'll see here right there, yeah, that's right around 2.16. For the other one, negative 1 minus root 10, that is negative 1 minus root 10 is going to be negative 4.16. So if you go 1, 2, 3, 4.16, yeah, that's right around where that that focus is as well. Okay, so we just double checked our work there. All right, now one more thing that we need to find is finding the equations of the asymptotes. Now this is pretty straightforward actually. If 1 over 3x represents the parent function of the asymptotes, then remember what we do. We just shift it over to the left by 1 and shift it up by 2. So we can just apply that into our equation. What we can say is that in the equation y minus 2, it has shifted up by 2, is equal to, what's our slope again? It's plus minus 1 over 3 times x, and then what is the horizontal shift? We said x plus 1. It had gone over to the left by 1, like that. Okay. If you want to rewrite it a different way, then you can move that 2 over, so you get y is equal to plus minus 1/3 times, oops, I don't need parentheses there, 1/3 times x plus 1, and then add a 2 there, like that. Okay, so that's going to be the equation of your asymptotes. And then here is the center, vertices, and foci. Okay, that was a big problem right there.